Yeah, Flippy Broadcaster just crashed on me. Which microphone is it on? Right. Yeah, this stupid Procaster. Don't know why it did that, but anyway, it's back on. So yeah, I was just saying, yeah, this gain thing. It's for the trace height, so I don't need to mess with that. I'll still have to find this test point C8, and I don't know where it is. You know, they should put an index of test points with the page numbers referenced to them instead of blindly looking for them, because they don't do that on here. What the heck is 57? Ah. Right, 57's marked there. And that is a trigger according to this it should be 35 millivolts. Peak to peak. Oh god, I'm not going to measure it on the scope. I don't know if I can use my own scope to measure it, I don't know, I might get a weird effect, I don't know. Let's not. So what's this C8 all about? What's that one? Are you going to bed, Hyde? Well, it's over. It's to the other side of the room. I could turn it on. Yeah, I could turn it on actually. See if my lead will reach though, because I don't want to be dragging it over here. Because I tell you, it's adding up, and I've got stuff lying around. Let me just see. Let me see if I can, if the probe lead would reach. Might do. Oh God! It's 2 inches too short. Well, I could move the scope closer, I suppose, because it's important really to get these readings right on here really. Let me just see now. If I move this oscilloscope a little bit nearer, I see I've got a proper scope probe here. Look, oh, right, I've got a proper ×10 probe here. I'll have to clip something on here to get a good at ground. Let me just move this camera a bit. Now, if I move my oscilloscope a little bit without electrocuting myself, because it is on, maybe I can get it near enough to get to the test point. Ooh, I think I can actually. That's C8 though, that one. Let me see, which one is it I'm looking at? It's 57, it's the test point 57 I want, and that's underneath. That's down there, so can I get in there? Yeah, I can. I can reach now. This ground wire is broken, look. There's no clip on the end. I really need to mend this. I really do, because this comes out, you pull this clip out like this, look. I'm thinking what I need to do is put a new lead on here. I think I might do that, because this probe has been in need of a little bit of maintenance for a long time. So it's got a heat shrink on this end, so I can take this clip off. Right, I can cut this heat shrink off and put a new wire on with a clip on. A clip on the end. I just have to find an old and it needs to be properly earthed, you see. So right, I'll just try and put the camera on full screen. Right, it's a good probe. I've had this a long time. They're bloody expensive to buy, these things now. It's gold tipped, gold on the end. Not many people have proper probes, and I'm lucky to have that because they're not cheap. Oh yeah, I could just clip a test lead on, yeah, I can do that, yeah. So right, let me just I just don't want to have a short circuit anywhere. I just don't like bare wires floating about, you know what I mean? That ground wire could touch something and short something out, and I'm a bit worried about that. So I'll get my clip, which I've got another clip over here. I've got a yellow lead here, so I'll clip this onto here. And I'll wrap some tape around so I don't accidentally short that out onto anything. And then I'll put the other scope on. Actually, what settings do I need? It says on here, it says I need to be on 5 M5 division, so that's 5 milliseconds, 5 volt division, so it's 5 M 5 volts division, so I think that's right. Hang on. So if you look at this section here, because I need to check everything, it says 5 milliseconds, and that looks like is that 5 volts division? I'm not sure, because that looks like an S to me. That looks like S, not an, that doesn't look like a 5 to me. According to this, it should be almost a triangle, but a square, slightly tilted waveform output. And I want to check that that's right. And I think Phil's scope is accurate. 5. Oh, maybe it's just 5 milliseconds. Maybe that's what it means, 5 ms. And I'm measuring 35 millivolts, so I want to be on. I want to be on. A high sensitive setting, so it wants to be on the. Yeah, that's it, yeah. I'm not thinking straight right now. Let me just go and calibrate, let me just go and set up that other scope a minute. I want to make sure I'm on the right channel as well. So, I want to be on 5 milliseconds. Turn it on. I want to be on channel 2. what volts division do I need to be on? What is it? Division 35 millivolt. Hang on a minute. I'm confused right now. It's doesn't. Oh, hang on. Here we go. Right. It's got 50, 20, 10 millivolt range. It hasn't got 35. So I need to be on. So if I set it to 5 millivolts division, no, 10 millivolts division, right? If I stick it on 10 millivolts division, then I should have 3.5 divisions for that. So 10's a good number to be on. Let me just set this up ground. Right. I'm terrible. I'm rusty. I'm rusty as hell. 10 volts division, yes. Yeah, but it'd be 3.5 divisions, yeah. Well, I'll tell you what. Let me just put the camera. So you can see the other scope a minute. The wires are tangled up. Right, it's not going to read anything right now because I'm not connected up, obviously, but I don't know if you can see the scope. Just get this on it. Get this to sit on this fan. Ah, stupid thing. Come on. Okay, right, alright, I won't worry about the camera then. Yeah. I can't stick it on that fan, it keeps falling off. It's going to be hard for me to see it though because it's right across the room. But it'll be easy to, it's actually easier on the 10 millivolt saying than it would be. It's pretty, it doesn't have one of them memory things where you can remember the. I'll clip this on ground. Right. Oh, what do I need to be? Oh, maybe the oscilloscope, this scope I'm testing also needs to be on 5 millivolt as well, which is confusing. So, I don't know. I'll stick this down to maybe I need to, no, maybe I just need to ground it while I'm testing. I don't know if I'm supposed to have a signal coming in, you see, when I'm testing this. Yeah, that's a good idea. Put the camera on the other scope, then watch the screen. Yeah, that's a good idea. Because I can't see from me over here very well. I'm like 4 feet away. Yeah, good idea. I'll have to fix something up. I have to find something to stand. Oh, hang on. I'm going to get what confused. I have an idea. This thing better not fall. I tell you, it'd be disastrous. This piece of iron, this G-clamp, I am going to stick my G-clamp between the table. I'm going to attempt to use magnets. Actually no, I'll clamp a G-clamp onto the table. Right. Then I'll have a really good secure point to stick a magnet thing on it. Right, so I'm going to clamp my G-clamp onto this table. That's good. Ooh, no, the table's falling over now. Uh-oh, I need to move it a bit further that way. Hang on. This clamp is heavy. Right, okay, it's gonna help. I'll clamp it, tighten it there. Right. Ah, that's tight. I need to put some heavy on the other side. Just a minute. Right, that transformer's heavy, that'll... Ooh! Bloody thing's falling over now. Hang on. No. Balance. It's all about balance. One of them things over there. Stick this transformer right in the middle. That's going to hold it. That's better. Okay, it's balanced now. Right, now I'll just get a magnet. Nice big magnet. Oops. Wires. What's that called? Drop the microphone. I've still got my microphone wires. Uh-oh, I've made a mess of something. Yeah. A minute, I'll just sort this microphone out now. Ugh. Okay. Right. Can you still hear me? Yeah. Sorry about that. I need to find some magnets. I've got plenty of those. Yeah, it's because I stood on the flipping wire. Nearly broke the plug. Alright, so if I get the camera now. Oh, this is going to be weird. The camera's going to be at a funny angle. I'm going to get it to stay on there. That's no good. I need to put the wire on the other side of me. Oh, actually. This flipping wire is too short now. Maybe it'll work. Maybe. need more magnets. It's not strong enough. I'll stick that like that. Ah, shit, I just pressed the button on this camera. It's going to do a bloody video capture thing now. Screen capture or something. I hope not. Just a minute. I need more magnets. Those cameras, I hate them because they've got this button on them, and you press the button and a stupid program pops up with a picture that you've just taken which you didn't want to take. Well, maybe it's not going to do it because it's already been used. Right. Stick some magnets on here. Huh. This wire's a bit tight. I hope it's alright. Hang on. Hang on a minute. It's not lined up properly yet. Wrong one. Stupid. It's out of focus. I don't know what's going on with it. It's blurry for some reason. Why is it blurry? I'm trying to brighten this down. Intensity. Oh, that's better. Right, turn the intensity down. Just the focus. Okay, that seems to be good enough. Okay, I can just about make out the divisions. I need to turn that other light off because it's reflecting. Ah, that's better. Right, I can just about make out the divisions on there. Actually, turn the light out, it's made it harder to see the divisions, but no, I'll have to turn that light back on because I can't see the divisions very well. One, two, three. I can just about make them out. I have no idea whether or not, it doesn't really tell me on that diagram. doesn't tell me if I need to be injecting a signal or not, but I'm just going to do this first and see what happens. I'm going to be connecting to test point 57. Right. Right, I'm on test point 57 right now. Oh, it must have something to do with the input frequency I'm injecting. Well, that's looks like that's 15 millivolts. It's not 35, it's 15. But I'm on the wrong frequency. I need to adjust my frequency generator. So I'll take this off a minute. I need my frequency generator on the lower frequency, so I'm going to go down to the lower frequency, which should be 5 kilohertz or something. Let's have a look. Let's try again. Okay, yeah, I'm on the lower frequency now. It's not even a square wave, it's a triangle. It's a sine. Maybe I was supposed to be injecting a square wave. Let me switch to square. Oh god. Yeah, maybe I'm supposed to be injecting a square wave in there. Right. So this test point basically is representative of whatever frequency I'm putting in. And you know what? It changes based on what I select the selector to on the output on the scope. So if I'm on I'm on 2 volts division right now. So I put this on 5 volts per division, and you see it drops down though. So I don't know if I'm doing something wrong here. But that's 5 volts per division. And it's actually reading the same on that scope as well as mine. That's interesting. I don't know. I've just taken it up again because I need to look at this. It says 5 millivolts. You know, maybe I'm not supposed to be reading on a separate scope. Maybe I'm supposed to be just looking at what's coming out on this scope when I'm supposed to be injecting a signal into it. Yeah, I haven't found this in the setup procedure in the circuit manual. I haven't seen this. I'm just gonna have to think. Oh, actually, that's probably right. 5 milliseconds, 5 volt division. That's probably what it is. And I'm on 5 volt division on this tele equipment right now, and I'm actually getting a deflection of about 1 gradient right now. Let's change the frequency and see what happens. Yeah, I'm not seeing any changes in the amplitude at all. I changed different frequencies. So that appears to be actually a bit low. Maybe not. There's probably something more about this in the manual. I just have to read it. So when I change this, when I change the voltage on the input on this tele equipment, it actually goes up on the other scope as well, though. So when I change the settings, I'm on 1 volt per division on the tele equipment, and it's going up and down on the other oscilloscope as well. So this is the actual input after it's been through the voltage selector switch. So whatever I set this to, so on the 5 volt division, which is probably what it's saying on there, 5 milliseconds, 5 volt division. Well, how can it be 35 millivolt if it's actually... How the heck do you measure 5 millivolt on the 5 volt range anyway? That would be very difficult. Because if I stick this on the on the 0.1, which is 100 millivolt range, it's off the scale. It's way off scale. So yeah, I must be not. I must be injecting too much signal. That's all I can think of. And I can't easily turn my signal down on at the moment without knocking the frequency off either. Well, at least I know what that test point's for anyway. It's you see, there's something not working properly on my signal generator at the moment. The actual output, and I think I know why. My output is supposed to go through the audio amplifier, which I've got built into it, and then it goes to the audio amplifier, and then I use the volume control on it to adjust the output. Yeah, I'll have to pull my frequency generator apart sometime and do some reconfiguring on it. I think, because I need to put that meter. I need to have you know, my frequency meter, my frequency generator. I've showed you it before. Yeah. What I'm thinking of doing is. I've actually got this meter in there, which is just an analog meter. It's just a needle. It might be an idea for me to pull that meter out some point and get a frequency counter and a dB meter or something and put that in there. Then I'll be able to properly calculate exactly what output I'm sending to the socket, and it would make more use. It'd be more useful. Because that meter that's in there is not doing anything right now. I really could do with a built-in frequency counter to show me what frequency I'm sending out, as well as how many millivolts I'm sending out as well, which would be very useful. I might have a look online sometime and see if I can find a digital meter that can actually build into this case. Because when I built this years ago, back in '91, I never finished it. You see, I never actually finished building it. I built the oscillator circuits and all that, and most of the switches are not connected to anything. I got halfway through building it, and then I got sidetracked with work, like you do. And because it was generating a frequency, that's all I cared about for testing audio equipment on, which is all I was using it for. So I kind of got sidetracked. I never really finished it. And back in the 90s, let's face it, finding a frequency counter back in the 90s, cheap, that wasn't expensive, was virtually impossible, because it was all Japanese stuff. It was expensive, and so I mean, it wasn't financially attractive to add a frequency counter into the meter, into this signal generator at that point in time. But now it's a lot cheaper. You can buy these things for tuppence light. So it makes sense that I should do some more work on this frequency generator at some point and build some proper meters into it. Well, anyway, as I say, I'm just having some weird sort of I'm just not getting you see that output that is on the that output that's marked in the graph there is dependent on what I'm putting in. So I think I'm supposed to be putting in a certain amplitude in, and I haven't got the right amplitude going in. So how can I measure it on that transistor if I haven't got the right amplitude going in? I can't. That's just it. Because there's a setup procedure in some of these diagrams, some of these manuals. If I can find it, let's see, what page am I on? page am I on? What, tell me. Oh, I'm on 27. Right, I'm on page 27. Right. This must be part of the setup further up that I've missed. So if I can find where it refers to figure what figure is this one? Don't tell me what figure I'm on. Should say at the bottom. Must be on the other page. Oh, it says here at the bottom. It says all waveforms. It says here all waveforms measured with calibrated waveform. With calibrated waveform. That's cal. Fed to both channels volts division to 0.1 trig selector to channel 1 and time division to 2 milliseconds. Well, I'm not feeding a calibrated waveform in, that's the problem. Yeah, well obviously that's what needs to be done. That's what I'm doing wrong. I need a calibrated waveform. It has to be the right input waveform. So there'll be some more stuff about that probably further up the page. So yeah. Yeah, okay. Right, 35 millivolt on the base and 5 volt on the collector. Let's have a look. Yeah, that's probably it. Yeah. Yeah, that's right. Yeah, there's there's another graph there. Yeah, it's plus 6 volt. There's actually right there. It's just 5 milliseconds division. It says plus 6 volt about halfway on the waveform. Well, let's just see if I can measure that. Transistor 23 is easy because I could just stick the probe directly on it. I need to measure that with my meter though, really. I'll stick my meter on it and see what voltage we've got. Right, transistor 25, where's that? Oh, the flipping transistor's not it's not a metal can, it's a plastic package, so I can't easily do that. So there should be another test point on there. Let's see. Collector's connected to. Actually, the collector transistor 25 is connected directly to C25. So yes, I can measure that. It's a twisted pair wires things. So all I have to do is stick my take that to ground. Sorry you won't be able to see much right now, but so if I connect to that one of these connections on this thing, I should actually get 6 volts. I'm on the DC range. I am not getting anything right now. I'm sorry, Hyde, I'll have a look. Yeah, 6 volt offset, 1 volt peak to peak. Yeah, let me just let me stick the scope probe on that collector. You see, it depends on what I'm putting in. You see, that's the problem. I have to be putting in the right. Well, that's with the probe on one light lead. Oh my god, that one's the high one because it's gone off scale. It's gone right off scale there. I've got my voltage division on that meter. That's scope too high now. I need to be. I need too low. I need to be higher up. So I can put this on. I'll stick this on 1 volt. Where's the right? I'll stick this on 1 volt division. Because it was going off scale. Let's see what it says now. I'm too high a setting now. 7 volts division. What? What? Oh, question volts division. Right, hang on. I'll stick this on. I'll stick it on 0.2 volts the division, right? It's on 0.2 volts the division. Let's have a look at what it is. Right, okay, that's what we're getting on the scope. So it's on 0.2, so that's it's only 2 volts per division actually reading on there. Right, so it actually appears to be low, doesn't it? But it depends on what you see. I'm not putting in a calibrated frequency right now. That's the problem. I have to be putting in a proper calibrated frequency in, which I'm not. Actually, it will change if I adjust my attenuation on the tele-equipment one. So just a minute. If I put this back on here, now I turn the knob to the. It should go up. Yeah, it is. It's going up. When I turn it. Yeah. So I've got my tele-equipment set to 1 volts. 1 volt per 1 volt per division right now. Okay. So 1 volt per division on the tele-equipment, and that's what I'm reading on the other scope right now. It's right, sorry about the loose connection. Yeah, I'm clearly not putting in the right input frequency. I'm using square right now. I am not putting in the right voltage. You got to be putting in a calibrated input frequency, which I'm not. Right, okay. Yeah, okay, so yeah, the tele-equipment set at the moment to 1 volts per division on the input, and that's 1, 2, 3, 4, 5. Actually, 1, 2, 3, 4, 5. Actually, 5.5 volts. On the tele-equipment, I've got 5.5 volts actually. All the way across. So I can't even see that properly at the moment. Just a minute. Just bring this full screen. And that one is reading that other scope is on what was it? 0.2? Hang on, I can't read it from here. No, that's yeah, that one's on point. This writing's so small I can't read it. At least my tele-equipment's got bigger dials. Yeah, it's on 0.2, this one is. But it's all dependent on what you're putting in. So that's what is about 0.2, 4, 6, 8. Oh, so, but yeah, that's 1 volt. Yeah, that's about 1 volt. So yeah, you're right, it's 1 volt. It is. So that's actually right according to that. You see, there's no guarantee that these scopes are perfectly calibrated either. They might be a bit off, you know. They might not be bang on. The voltages, well, I think the voltages are correct for my scope because I'd calibrated it, but I'm not sure about the voltages on the other one. I think they're a bit low on the other one, so it's probably right. It's probably reading correct. I'll be your estimate on the 1 volt from between peak to peak. So if I stick this on if I stick this on 1 volt, which it is there, then we should get 1 volt peak to peak when I put this thing on. Just a minute, let's put it back on again. Right, that, come on, connect with you. That should be 1 volt peak to peak. Right, that should be 1 volt peak to peak. Sorry about the the jitter, it's because I keep losing connection. So I think that's about right. Anyway, enough of that. I am happy about the stability with this scope. The teleequipment, it's definitely a lot better than it was. I need to go back to triangle. I'll go to triangle waveform actually. Right, let's go on a triangle waveform. Have a look at that on there. If I can get it on, it's not registering that. I'm probably too low. Take this back on 1.1. See if I can measure this triangular wave. And it's very weak. Go to the test point. There. Ah. I can't seem to get it on there. I need to be set lower. Right, okay, enough of that. Enough of that one for now. I've got a slight bit of instability on this triangle, so I'm going to try and correct it. Been warming up for a while though. That's better. I haven't actually tested this on the triangle waveforms. That's locking on okay. It wants to be. I'm supposed to set this up on 50 kilohertz anyway. Let's try the higher one. Hmm. Huh. Yeah, I'm going to have to do some more work with this Yeah, okay, Hyde, you sleep well. Have a good night's sleep.